Hello, welcome once again to Chemistry Meal. Chemistry Meal is part of Mathematics and Science Meal program where we use simplified method in dissecting the concept of mathematics and sciences. I still remain your friend and your brother and also your tutor, Engineer Ike Okechukwu. Today on Chemistry Meal, we are going to look at electrochemistry, part 1 of it. And in part 1 of electrochemistry, we'll be looking at the concept of oxidation and reduction. Subscribe to our YouTube channel if you have not done so, and make sure you follow us on Facebook at Mathematics and Science Meal. Also follow Engineer Ike Okechukwu on Facebook. Alright, let's begin today's lovely and wonderful journey. I promise it's going to be a very sweet journey on the concept of oxidation and reduction. Alright, now when we talk about electrochemistry, electrochemistry is an aspect of chemistry that deals with the relationship between chemistry and electricity. Yeah, chemistry is related to electricity because we know there is conversion of chemical energy to what? To electrical energy, and also there is conversion of electrical energy to what? Chemical energy. And we'll look at all this in electrochemistry. When you consider electrochemical cells, you use electrochemical cells to convert chemical energy to what? Electrical energy. And when you consider electrolytic cell, during electrolysis, electrical energy is converted to chemical energy. So there is a link between chemistry and electricity, and that's what electrochemistry is all about. And the foundation to electrochemistry is the concept of oxidation and reduction. So let's quickly look at the concept of oxidation before we now begin to look at reduction. All right, we'll begin. Let's look at oxidation. Oxidation. You know, anytime we talk about oxidation, one of the elements that will usually come up to our mind is oxygen. Once we hear us, so we always think about oxygen. And as a matter of fact, oxidation has a connection with what? With oxygen. But it's not just oxygen alone. There are so many ways we can actually talk about what? Talk about oxidation. Yes, there are so many ways. So we are going to define oxidation in 4 different ways. So let's begin. So we say oxidation can be defined in the following ways. So we can possibly define oxidation in the following ways. What's the first way? Number 1. The first way, number 1, we can see oxidation. Is the addition or gain of oxygen. So oxidation can be defined as addition or gain of what? Oxygen. So when oxygen is added to a substance, or when a substance gains oxygen, that is what? Oxidation. We can use an equation to represent that. I have this common equation. When carbon combined with oxygen, we are going to have carbon 4 oxide. So there is addition of oxygen. So oxidation actually took place here. So when there is oxygen added to what? To a substance, or when a substance gains oxygen, that is what? Oxidation. So addition of oxygen to an element is what we call what? Oxidation. But that's not the only definition of oxidation, because I said we're going to be looking at about 4 definitions of of oxidation. So what is another definition of oxidation? The second definition of oxidation is this. Oxidation is the removal or loss of hydrogen. So removal or loss of what? Hydrogen is also what? Oxidation. That's another definition for what? For oxidation. So oxidation can be addition of hydrogen. So when addition of oxygen. When oxygen is added, it's oxidation. Alternatively, we can define oxidation as removal of what? Hydrogen. Okay, when carbon 2 oxide reacts with steam, when carbon reacts with steam, this steam, hydrogen will be removed from this steam. So we have carbon 2 oxide and hydrogen. So we just removed hydrogen. So this is also what? Oxidation. This is also oxidation. So removal of what? Hydrogen is what? Is oxidation. Removal of hydrogen. So we also have the third definition of what? Of oxidation. Oxidation can be defined also. Oxidation is loss or removal of electron. So whenever there is loss of electron, oxidation has taken place. So oxidation is removal of electron or loss of what? Loss of electron. So loss of electron is oxidation, or removal of electron is oxidation. So quickly, we can have this. We can have, let's say I have ion 2 losing one more electron to become ion 3. So there is loss of what? Loss of electron here. Alternatively, we can rewrite this equation. I can write this equation. You know, when we are writing equation, we don't normally use subtraction sign, we use addition sign. So alternatively, I can write this as Fe2 plus ion 2, then Fe3 plus 1 electron. Plus an electron. So that shows loss of electron. This equation and this are the same. I used the negative sign here to show that electron was removed from what? From ion 2. So when an electron is removed, then we are going to have an increase in oxidation number. So we are still going to see that fourth definition. So loss of electron is actually what? Is actually oxidation. Then the fourth definition of oxidation, oxidation can be defined as increase in oxidation number or state. So increase in oxidation number or oxidation state is also what? Oxidation. So I will use the equation I used last to illustrate that. So if we have that ion 2 to ion 3 plus electron. Now the oxidation state of ion here is +2. But the oxidation state of ion here is +3. Now the oxidation state of ion just increased. So increase in oxidation number is what? Oxidation, or increase in oxidation state. So the oxidation state of ion increased from +2 to +3. That is a sign of what? Oxidation. So these are four definitions of what? Of oxidation, the common definitions of what? Oxidation. Now, the second concept we need to look at is the concept of what? Reduction. So let's see reduction together. Reduction. Now, reduction is opposite of what? Oxidation. That means when we reverse all these definitions, we are going to get the definition of what? Of reduction. So we say reduction is opposite of what? Oxidation. Thus, we can define reduction as follows. We can define reduction as follows. Number one, reduction is loss or removal of oxygen. Remember, we say that reduction is opposite of what? Oxidation. So if oxidation is removal, is addition or gain of what? Oxygen. Reduction will now be the opposite. So reduction is loss or removal of what? Of oxygen. Loss or removal of oxygen. So when oxygen is removed from a compound, that is what? That is reduction. When oxygen is removed from a substance, that is what? Reduction. So when you have a reaction and oxygen is removed in the course of the reaction, then that is reduction. And it's possible that when the oxygen is being removed, it will also be added to another substance in some cases, or it may not necessarily be added to another substance in the reaction. So if we have a reaction where we have copper 2 oxide reacting with sodium metal, and we form sodium oxide and copper, so we have this. So oxygen has been removed from what? From copper here. So there is reduction. Even though as the oxygen was removed, it was also added to sodium. So reduction and oxidation occurred here. And it is important for us to note that the two reactions usually occur together. That's why in the course of studying electrochemistry, we are going to look at the concept of redox reaction. That's reduction oxidation reaction. Because anytime we have addition of hydrogen, we also have removal of hydrogen. So anytime there is oxidation occurring, there is also reduction taking place. So the two reactions usually occur simultaneously. And we're going to see that as we look at one of the concepts in electrochemistry that we call redox reaction. We're going to see that redox reaction. So here oxygen was removed from what? From copper 2 oxide. That is what? That is reduction. Now another definition of reduction, which is directly opposite to the definition of oxidation, is gain of hydrogen or addition of hydrogen. So number 2, reduction is the gain or addition of hydrogen. So gain of hydrogen or addition of hydrogen will give us what? Will give us reduction. For example, when hydrogen is added, if we add hydrogen to sodium, I have sodium plus hydrogen, we are going to form sodium hydride. That's what we form. So hydrogen has been added here. So we form sodium what? Hydride. So the addition of hydrogen to an element or to a substance, any other substance, is what we call what? Reduction. Remember, we said that removal of hydrogen is actually what? Oxidation. So the opposite is now reduction. Then we have the third definition. The third definition of reduction is that reduction is gain of electron. So reduction is gain or addition of what? Electron. So gain or addition of electron is also reduction. Let's look at that. If I have chlorine gaining 2 electrons, we're going to have chloride ion. So we have this gain of electrons. So electron was added to this chlorine to give us this. So we have chloride ion. We have this. So addition of electron is also reduction. And that will bring us to the fourth definition, which we are still going to use this equation to illustrate. That is, reduction is decrease in oxidation number or state. So reduction is decrease in oxidation number or oxidation state. Now if we still use this equation, let's use it and illustrate that. Example, Cl2 plus 2E giving us 2Cl. Now this is a molecule of chlorine and it's at free state in uncombined form. So it did not combine with anything. When we look at the rules guiding oxidation number, we say that the oxidation state of element in free state is 0. So An element is in free state if it is not in ionic form and it did not combine with any element. That means it's not inside a compound. So when an element just exists as an atom or as a molecule, the oxidation state of that element is 0. So since this chlorine is existing as chlorine molecule, it is not inside a compound, it's not in its ionic state. So the oxidation state here is 0. Now here, the chlorine is in ionic state, so it's chloride. And we say that the oxidation state of a single ion, single simple ion, is the charge on the ion. So it means the oxidation state of this chloride ion is -1. That's the oxidation state. So you notice that the oxidation state of chlorine decreased from 0 to -1, because 0 is actually greater than -1. So there is a decrease from 0 to -1. And because there is a decrease in oxidation state, reduction took place. That's why we say that reduction is also decrease in what? In oxidation number, oxidation state. Alright, that's beautiful. So far so good on the concept of oxidation. Now I believe that you have mastered the definitions of oxidation and reduction. No matter how you're asked to define oxidation and reduction, you can be able to do so. But don't allow me to oxidize you or to reduce you. Which one do you want? To be oxidized or to be reduced? Don't mind me. We are talking about chemistry. We are not talking about any other thing. So in our next class, we are going to look at the concept of oxidation number. Yes, that's what we are going to look at. And we'll look at the rules that guide oxidation number. Those rules are very important, because for us to carry out calculations on oxidation number, we need to know the basic rules guiding oxidation number of elements and also that of radicals. Thank you for watching Chemistry Meal today. Till we meet again in our next class, continue to enjoy all our meals on our Facebook platform and also on TikTok. Yes, I think we are there also. We are on TikTok. You can go to TikTok if TikTok is your favorite. You can go to TikTok and also watch our videos. Then subscribe to our YouTube channel at Mathematics Meal 1, so that you will have a lot of meal to enjoy in mathematics and in all the sciences. Thank you for following us till now. I still remain your friend, your brother, and also your tutor, Engineer Ike Okechukwu. Bye.